triangles today, but this is what you use in right triangles when you can't use the Pythagorean theorem. It's not 30, 60, 90, and it's not 45, 45, 90, okay? So what we have to use is trigonometry whenever we have that scenario. But you always want to look at your triangle, and you want to use the best tool. If it's a 30, 60, 90, that's what I would use. It's easier. It's quicker, okay? You don't even have to have a calculator. All right, so we're going to talk about trigonometry today. Now, what is trigonometry? It's the study of triangles. There's a whole semester worth of class called trigonometry that comes after Algebra 2. And trigonometry comes from two Greek terms, trigon meaning triangle and metron meaning measure. Okay, so it's the study of triangles. And we are going to talk about three different trigonometric ratios today. They're the sine, the cosine, and the tangent. Okay? And we're going to use these to find missing measures within right triangles. Okay? But we're going to first talk about how to set these ratios up. Okay? All right. Okay, so the first one we want to talk about is the sine. Okay? And these work, and we're going to, these work with the acute angles of the right triangle. Okay? And the sine of an angle, it looks like sin, but it's really sine because they just had to abbreviate it. The sine of an angle is the length of the leg opposite the angle over the length of the hypotenuse. So if we're doing the sine of A, we come over here to angle A, and that ratio is the opposite leg over the hypotenuse. Okay? So opposite leg over the hypotenuse. So if I'm doing the sine of A, the opposite leg is BC, and the hypotenuse is AB. I can also do it with the other acute angle, okay? If I wanted to do the sine of B, then that would be the opposite leg, which is AC, over the hypotenuse, which is AB. So we remember this as opposite over hypotenuse. Okay, that's our sine, opposite over hypotenuse. Okay, the second ratio is cosine. Okay, and they abbreviate that with just the COS, but it's still cosine. Okay, so if I wanted to find the cosine of an angle, it is the adjacent leg. And adjacent means that it's right next to it, so it touches that angle. The adjacent leg over the hypotenuse. So that is AC over AB. We could do it with the other angle, the other acute angle, adjacent over hypotenuse. So the leg adjacent to B is BC over the hypotenuse, AB. So when you want to do the cosine of an angle, the abbreviation for that is adjacent over hypotenuse. Adjacent over hypotenuse. And then the third one is tangent. Okay? And tangent of an angle is the leg opposite over the leg adjacent. Okay? And we abbreviate that opposite over adjacent. So if I wanted the tangent of A, that's opposite, which is BC, over adjacent, which is AC. BC over AC. I could do the same thing with the other acute angle, angle B, and its opposite is AC over the adjacent, which is BC. Okay, so my sine is opposite over hypotenuse. My cosine is adjacent over hypotenuse, and my tangent is opposite over adjacent. And we've come up with an acronym to help us remember. And this acronym is SOHCAHTOA. Okay? Now you gotta know how to spell it, or it messes you up. Okay? So it's SOHCAHTOA. So we have our sine, and you always take the sine, the cosine, and the tangent of an angle. So it's the sine of whatever the angle is equals opposite over hypotenuse. And this is our SO. Sine is opposite over hypotenuse. Cosine. The cosine of the angle is adjacent over hypotenuse. Okay, so cosine is adjacent over hypotenuse. And then our tangent of the angle is opposite over adjacent. So TOA, tangent is opposite over adjacent. And so when you get your test, not only are you going to write those 30, 60, 90 rules and the 45, 45, 90 rules, you're going to write SOHCAHTOA, okay? All right? All right. So right now, we're going to just talk about how to set these fractions up, okay? These ratios up. Okay, so we want to find the sine, the cosine, and tangent of angle R, okay? So we want the sine of angle R, the cosine of angle R, and the tangent of angle R. Okay? And here is angle R. And remember SOHCAHTOA. Okay? Alright, so we go to R and we want the sine. And remember, sine is opposite over hypotenuse. So what's the opposite? 9. What's the hypotenuse? 15. So that ratio is 9 over 15. And you need to reduce it. What goes into both 9 and 15? 3. So 3/5. Sometimes they ask you to give the decimal equivalent. Okay? Sometimes they just ask for the ratio. Just do whatever they ask you to do. Okay? The cosine of R. Remember, cosine is adjacent over hypotenuse. So what's the adjacent? 12 over the hypotenuse, which is 15. So that's 12 over 15. That reduces to 4/5. And if they ask for the decimal equivalent, that'd be 0.8. What about the tangent of R? The tangent of R is opposite over adjacent. So what's the opposite? 9 over the adjacent, which is 12. So that's 9 over 12. That reduces to 3/4, which is 0.75. Okay? So that is the sine, the cosine, and tangent of R. Now let's do the same thing with S, because you can do this with the acute angle. So now we want the sine of S, the cosine of S, and the tangent of S. So we go to S, and sine, opposite over hypotenuse. What would that be? 12 over 15, which is 4/5, which is 0.8. What's the cosine of S? Cosine is adjacent over hypotenuse. What's adjacent to S? The leg adjacent. 9. And the hypotenuse is 15. Now, when you're using cosine, you really have two adjacents, right? But it's the adjacent leg, and then the other one is the hypotenuse. Okay, that's the one across from the right angle. So that reduces to 3/5, which is 0.6. Okay, and then the tangent of S is opposite over adjacent. So what would the tangent be? Okay, the tangent is opposite S, 12 over 9. So 12 is opposite, 9 is adjacent. That reduces to 4/3, okay, which is 1.3 repeating. Now, sometimes they ask you to round it to a particular place. A lot of times it's the nearest 10,000th place. It could be the nearest 100th. Just do whatever it asks you to do. So read the directions, okay? Okay, now, what this is doing is setting the stage to be able to find missing sides and angles, okay? Because your calculator does this magic inside, and it helps us come up with the angle measures and the side measures with this information, okay? Let's say that I wanted to find out angle R, okay? Now, back in the olden days, when I was in high school, there was a chart in the back of my trig book, and I could just reference the chart. I think I even used it in geometry. We were getting the scientific calculators, but not everybody had them. So if you didn't have them, you had to use the chart. So if I wanted to find out angle R, I'm going to show you how to do it on your calculator, but this is how we used to do it. Kind of just to show you I wanted to find out angle R, I could do this little chart. Okay? You see how it has the different columns. It has angle, sine, cosine, tangent, and then it repeats angle, sine, cosine, and tangent. So, what was the ratio for the sine of R? What was the fraction or the ratio? Point 3/5, which was 0.6, right? Okay, so I would look in the sine column, because that's the one I used, and I would go down till I found the thing closest to 0.6, which would be this one right here, okay? So under the sine column, 0.6 goes with the 37 degrees. So that angle R is 37 degrees, okay? Okay, how about, let's do one with S. What was the tangent of S? 1.3 repeating, wasn't that what it was? Okay, so I would go in the tangent column, and I would find the thing closest to 1.3 repeating, which would be about this right here, which means that this is a 53-degree angle, okay? Well, that's how we used to have to do it if we didn't rely on our calculator. But I'm going to show you how to use your calculator, okay? So let's go ahead and we found that angle R was what? What was it? Angle R, 37, right? This one was 37, and this one was 53. And it works out really well because all the angles have to add together to equal 180, right? This is 90. If this is 37, this has got to be its complement, right? These have to be complementary in a right triangle. Okay? Now, in your homework, they don't, like when you do these ratios, I won't ask you to find the angles at first. I want you to kind of practicing, and that's what we were doing here. I was just kind of showing you how the chart works, okay? All right, and so we're going to practice just a little bit more, setting up these ratios, and then we'll talk about how to use the calculator. Okay, now, it's going to ask you to come up with the sine, the cosine, and tangent of the 30-degree, 45-degree, and 60-degree angles. So what this means is they want us to go back and use our special right triangles, okay? And remember, in the 45, 45, 90, what was true about the legs? They were the same, right? Okay, we used x for it, correct? But we're going to put a value in there. So we're just going to be easy, and we're going to let both of those be 1, okay? And so if both of those are 1, then the hypotenuse is what? Right. Just radical 2 or 1 radical 2, same thing, right? Okay, in the 30, 60, 90, everything was in terms of the short, and that's what we let be x, right? So instead of it being x, we're going to let it be 1, which means the hypotenuse is 2, and the long would be radical 3, right? Okay, and so if it asks us to find the ratio for sine, cosine, and tangent of these angles, I'm going to draw these pictures and use these numbers. Now, I really could use anything. Like I could put 2 in here and 2 here, and this would be 2 radical 2, but when I set the ratios up, it's going to be the same. Okay, so 1 is just easier to use, all right? Okay, so what I'm going to do is I'm going to find the sine of 60, the tangent, not 60, the sine of 30, the tangent of 30, and the, and the cosine of 30. Okay? All right. So if I want to do the sine of 30, then I come over here to 30, okay? And what would the sine be? Opposite over hypotenuse. Remember SOHCAHTOA. Okay. So the sine of 30 would be 1 over 2. Okay? What would the tangent of 30 be? The tangent, it'd be 1 over radical 3. Okay? But I can't have a radical in the denominator, right? Okay? So I have to rationalize it. And I end up with radical 3 over 3. What about the cosine of 30? Radical 3 over 2. And I don't have to do anything to that one, right? Okay, Then I'm going to find the sine of 45, the cosine of 45, and the tangent of 45. Okay, so the sine of 45, it doesn't matter which 45 I use, again, is opposite over hypotenuse, so what would that be? 1 over radical 2. I can't have a radical in the denominator, so I rationalize it. And I get radical 2 over 2. Cosine of 45. Again, adjacent over hypotenuse, that would be 1 over radical 2, which is radical 2 over 2. What about the tangent of 45? Opposite over adjacent, so it would be 1 over 1, which is 1, right? Sine of 60, cosine of 60, and tangent of 60. Okay, so the sine of 60 would be what? Radical 3 over 2. Cosine of 60, adjacent over hypotenuse, that's 1 over 2. And then the tangent of 60. Radical 3 over 1, that's opposite over adjacent, so that would be radical 3. So again, we're practicing setting these ratios up, but we're practicing with our special right triangles, okay? The idea is still the same, okay? All right? Okay. Now, it's the fun part. Now we get to figure out how to use those calculators, okay? Okay. Trigonometric ratios can be used to find the missing measures of the triangle. Now, I don't want you to forget about your Pythagorean theorem and your 30, 60, 90, 45, 45, 90, okay? So when you go to do these problems, you want to look at the picture and figure out what you're dealing with, okay? You look at this, this is a 32-degree angle. So it's not 30, 60, 90, it's not 45, 45, 90, and I can't use the Pythagorean theorem, okay? So I have to use trig. Okay, right myself a toe up here. Okay, so what I do is I look at the angle and what I have in regard to the angle, okay? So I have a 32-degree angle, and I'm looking for the opposite, and I know the hypotenuse. So opposite and the hypotenuse, which trigonometric ratio am I going to use? I'm going to use sine, opposite and hypotenuse. So you always take the sine of the angle, in this case it's 32, and that's equal to opposite over hypotenuse. Okay? And so now I have an equation, and I want to solve for x. Now, the sine of 32 is a number. Those stick together like glue, okay? These always stay together, all right? So this is a number. And so I want to just get x by itself. So I look at what's happened to x. It's divided by 15. I do the opposite operation. What do I do to get x by itself? Multiply. So I multiply both sides by 15. Okay? These 15s cancel, so in my calculator, I'm going to type in 15 sine of 32, and I'm going to hit enter. So everybody type that in your calculator. 15 sine of 32, and hit enter. What'd you get? 7.9. Okay? So x is 7.9. Okay? If you didn't get 7.9, you need to raise your hand. Okay? We need to figure out what you did wrong, because you got to know how to do this when you get home with your calculator. Okay? All right. Let's look at the next one. Okay? In this one, again, I go to my angle. It's a 67-degree angle. Okay? That means we got to use trig. Okay? What do I have in regard to it? I have the opposite, and I'm looking for the adjacent. Okay? So what does that mean that I'm going to use? Okay, like, give me 15 minutes, or 10, 15 minutes. Okay, thank you. Okay, okay, so So we said opposite and adjacent, and what do we use for opposite and adjacent? Tangent, right? Opposite and adjacent goes with the TOA, right? Tangent. So again, you take the tangent of the angle, which is 67, and that is equal to opposite, which is 21, over adjacent, which is x. Now we have a bit of an issue with this one because the variable is in the denominator. You can't solve for a variable if it's in the denominator. So it's like getting rid of a fraction. You blow it up, okay? And so to blow it up, I multiply both sides by that denominator, okay? And then they cancel. So that ends up being x times the tangent of 67 equals 21. And you don't necessarily have to put that dot there. I'm just showing you that dot so you'll know it's multiplied. Okay, so if this is multiplied together to get x by itself, what am I going to do? Divide. So I divide by the tangent of 67. Remember, that tangent and that angle stick together like glue. Okay, so I divide both sides by the tangent of 67. That cancels. So in my calculator, I'm going to type 21 divided by the tangent of 67. And hit enter. So 21 divided by the tangent of 67. And what did you get? 8.9. Everybody get 8.9? Okay, so the answer is 8.9. All right. So, now, one thing you can do with tangent, okay? One thing you can do with tangent is instead of using this angle, I could use this one. What's the measure of this angle up here? If this is 67, this has got to be 23. So I could have used that angle, and then my opposite is x, and my adjacent is 21. So that's the tangent of 23 equals x over 21. You can do that on tangent. You can't do it on sine and cosine, but you can do it on tangent. You can use the other angle, okay? And that keeps the variable from being out of the denominator. It saves you one step, kind of. Not really, but kind of. Okay, you get the same answer. All right. Now, what happens when the angle is what's missing? Okay? All right. So again, your thought process is the same. You look at the angle, which is the unknown, x, and you look at what you have in regard to it. Okay? I have the opposite and the hypotenuse. Which one works with opposite and hypotenuse? Sine. So you take the sine of the angle, which is x, and that is equal to opposite over hypotenuse. Now, when looking for an angle, you have to use the inverse sine, cosine, or tangent, okay? So find this button, and it should be right above the sine. You see that? Okay, so to access that, whatever color it is, you have to hit that button first, and then sine, okay? So it's usually second. Some calculators are inverse. Okay, so you hit second, and then the sign, and that's what pops up, and usually a parentheses. Okay? All right, so second sign, then you type this in as a division problem. 3 divided by 5, and hit enter. So you do second sign, 3 divided by 5, and what did you get? 36.8 something, right? Okay? Usually the angles, they have you round to the nearest whole number. So this would be 37 degrees. Okay? Usually the sides, they do tenths, and the angles, they do whole number, usually. Just make sure you read the directions. Okay, here's another one. All right, so again, we look at the angle, and we look at what we have in regard to the angle. If this is x, what do we have in regard to that angle? Adjacent and hypotenuse. Which one do we use for adjacent and hypotenuse? Cosine. So we do the cosine of x equals adjacent over hypotenuse. Okay? Now, because we're working with the angle, that means we have to use what? The inverse. So we have to type in second cosine, that little -1 thing pops up, and we do 7 divided by 11. Second cosine, 7 divided by 11, what'd you get? 50 degrees, right? 50.4, so 50 degrees. All right, so when you're looking for the angle, you have to use the inverse. If you're looking for the side, it's regular sine, cosine, or tangent. Okay, we've got two more. These are pretty quick. Okay, Dakota is standing on the ground 97 yards from the base of a cliff. Using a theodolite, he noted that the angle formed by the ground and the line of sight to the top of the cliff was 56 degrees. Find the height of the cliff to the nearest yard. Okay, so here is Dakota. Okay, here is a cliff. Okay, he is standing 97 yards from the base of the cliff. Now the cliff is going to make a right angle with the ground in a perfect world, right? Now he's got this little thing called a theodolite. It's a little tool that measures the angle with the ground and the line of sight to whatever it's looking at. Okay? This measures the angle. And it says that that angle is 56 degrees. The height of the cliff is what I'm looking for, and I'm standing 97 yards away from the base of that cliff. Okay? All right. So, what am I going to use to figure out how tall this cliff is? Tangent, because I have opposite and adjacent. Okay? If hypotenuse is not involved, then you have to use tangent, right? Okay? All right. So, I'm going to do the tangent of 56 equals the height of the cliff, which is my opposite, over 97, which is my adjacent. All right, so am I going to have to use inverse tangent or regular tangent? Regular. And I just multiply both sides by 97. So in my calculator, I'm going to do 97 tangent of 56. And I get, what does it say? Find the height of the cliff to the nearest yard. What would that be? 144 yards. Okay. What? You probably typed in the wrong number. Okay. All right. Any questions on what we did there? Okay, one more. A plane takes off and climbs at a 12-degree angle. Is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles away from the runway? Or does the plane need to increase its angle of ascent? Okay, so what happens is at the airport you have this airplane, and it takes off at a particular angle. It says it's 12 degrees, right? Okay, so it takes off. We have this mountain that's 11,088 feet, okay? He is 12.5 miles away from this mountain, okay? We need to know that if traveling at this angle of ascent, is that going to be enough to clear the mountain, okay? So we're going to let this be our unknown, because we need to know how high he's going to get going at that, whatever, okay? All right. So what am I going to use to determine how tall those mountains are? Tangent. So you take the tangent of the angle, which is 12, and that is opposite over adjacent. Okay. So what do? Multiply both sides by 12.5. Okay, so we do 12.5 times the tangent of 12, and you get 2.7, approximately 2.7 miles is how tall the mountain is, right? Now, they're telling me how tall it is in feet. So I need to change the height in miles to the height in feet. How many feet are in a mile? 5,280. 1 mile equals 5,280 feet, okay? So I'm going to take 2.7 times 5,280. And that gives me 14,256. So, is traveling at 12 degrees over 12.5 miles going to be sufficient to clear the mountain range? Yes, it will. Okay, good. All right. Any questions? What are you going to write at the top of your paper when you get your test? SOHCAHTOA, and you're also going to draw those little triangles, right? And put those rules down there. Okay.